let us look at this one. This is November 2010 question 6. That is November 2010 question 6. You can see now we have the line LP. Here's the line LP on this side with the equation y plus x minus 2. The equation of this line is y plus x minus 2 is equals to 0. That's good. And then from there, we know that it's a tangent at L. It is also a tangent at L. Right, to the circle with the center M, which is minus 4 and 4. Right, and also Ln is what? Ln is the diameter. Now you remember now the diameter is twice r. Then it means our r here, therefore will give us the diameter now, which is equals to 2, which is equals to 2r. Very important, right? Now from here now we can now go to say, also now they said LP is parallel to NQ. LP is parallel to NQ. Now, if they say now something is parallel, LP is parallel to NQ, what do you know about the parallel lines? What do you know about the parallel line? Of course, I know that if lines are parallel, they have the same gradient. Will you agree with me that to say the gradient of LP is equal to the gradient of NQ, right? Now they also said where P lies on the x-axis and Q lies on the y-axis. This is our x-axis there, and now this one is on the y-axis. Right now, let us look at the question. Now we've read the statement, which is very important, boys and girls. Each and every time, before you can answer the questions, make sure that you read the statement, you understand, or you can highlight all the information that is given on that statement. Right. Question 6.1. 6.1, they are saying now we must determine the equation of the diameter Ln. We must determine the equation of the diameter Ln. Okay. Now here's the diameter Ln, and this diameter is a straight line. Is that correct? Here's the diameter is a straight line. Now you will remember now for the straight line we must have y minus y1 is equals to m into x minus x1, or one will say y is equals to mx plus y is equals to mx plus c. Now immediately now, once you have the formula, now we can now be able to identify to say, for me to be able to use this formula, I need to have the gradient of that line as well as a point on that line. Of course, if I go back a little bit now to the gradient, for me to determine the gradient, I need to have 2 points on the line, right? Yes, we must have 2 points on that line. Now, if I look at Ln, do I have 2 points here? No, I only see 1 point here now, which is our midpoint, right? Now, if we have 1 point, then we cannot use the gradient formula, right? If you cannot use the gradient formula, what is it that we must do now? Then let us look at another information. We have extra information here. Yes, we have the tangent on this side, LP, and also we have the tangent on this side, which is NQ. Why the tangent? Because we know that they are perpendicular to the radius. Yeah, they are perpendicular to the radius. Right, now, let us now see. We have the equation of the tangent LP, which is y plus x minus 2 is equals to 0. Then, the first thing that we need to do is to write this equation in the standard form. We must write it as y is equals to mx plus c. Therefore, now you will see we are going to have y here is equals to minus x plus 2. Y is equals to minus x plus 2. Now you can see now we have our equation in the standard form. Then immediately now from here now I can now be able to see now to say, okay, the gradient of the tangent what? The gradient of the tangent there, LP, is equals to a -1. If the gradient of the tangent LP is equals to -1, what is the gradient of the radius? What is the gradient of the diameter? Remember now, if this is the diameter, now it means now, if I have to divide it into 2, we're going to have R1 on this side, R2 on this side, so that when we add the 2, they can give us the diameter. Right now, if we have to find the gradient of the radius, what is it that we're going to do? Because the tangent is perpendicular to the radius. Therefore, we know that m tangent multiplied by m radius is equals to -1. We know that m tangent multiplied by m radius is equals to -1. Therefore, now our tangent there is -1. Then we times by the radius, which is -1 as well. Then divide both sides by -1. Therefore, m radius here is equals to the positive 1. Why? It is very important always to remember that the tangent is perpendicular to the radius. Right, now we know that now the gradient of this line here, it's a what? It's a positive 1. Of course, now if this is a diameter, now we can say L, M, and N, they are on the same line. It means these points are collinear. If these points are collinear, then it means the gradient of LM is equals to the gradient of MN, or the gradient of LM is equals to the gradient of LN. Therefore, now I can now say, therefore, the gradient of what? The gradient of NL is equals to +1. Now I have the gradient, then it means now I can now be able now to say, therefore, here we have y minus y1 is equals to m into x minus x1, right? And then from here now we say, what is the gradient? The gradient is 1. Therefore, we have x. What is x1? Of course, we will have to use the point M, which is our center, whereby x there is a what? Is a -4, then it will be -4 here. And now the same apply, y1 is what? It's a +4. Right, now here we have what? We multiply everything by x. 1 times x is x. Negative times negative, it's a positive. Therefore, we have a +4. Right, this is a -4 on this side. When I take it on the other side, we are going to have a +4 as well. Therefore, now we have x +4. Therefore, this will be what? When we add the 4 together there, the answer then will be what? The answer will be a positive 8. Therefore, now 6.1, the equation of the line LN. The equation of the line LN is equals to what? Is equals to x plus 8. Is equals to the y is x plus 8. Right, now this was the first question.